Hello everyone. So in this demonstration, we'll see and discuss about the RADON data pipeline tool. And this is mostly about more focusing on the migration of data across multiple clouds. And this video will be part of the webinar on RADON data pipeline, automating data movement in clouds. So let's move on to this to the use case and we'll see the whole demonstration. So what we'll be discussing? What is the service? What is the use case we'll be discussing? So this will be the use case we'll be discussing, where user will upload some data manually to a minimal database, and that data will move to Amazon Lambda, and it will be processed. That image will be processed. First, the image will be grayscaled, and then it will move to another Lambda function that will blur the image, and the blurred image will be stored to Google storage, and it will be sent to also another fast function, and that fast function is inside the Azure cloud. The first function will compress the blurred image, and then it will store in one blob storage. So this is what we'll be doing in this demonstration. So before this, what we need, first of all, to prepare this service template, we need to have the RADON ID. We will use the RADON ID, and inside that we'll use the RADON GMT tool to prepare the service template. So here I have, before that, we need to log into Eclipse J, which is the RADON integrated development environment, and we'll log in here, and then we need to create a workspace. Okay, here we have already created in workspace. If you want, like, you can create a new one. Now, workspace webinar 1 I have already created, and once you have created the workspace, just run it, open it, and if you open, you'll see the RADON IDE, where in one side you can see all the plugins. Well, these will appear over here probably in few minutes. So here we can see all the plugins over here. So to prepare the service template using TOSCA, we need to open the RADON GMT plugin, and once you click over here, you can see the service templates, list of service templates, and the node types, and the relationship types, and other elements, including your artifacts, capabilities types, policies. So here we will use the service template tab, and using add new, we will create a new service template, and let us say the service template name is data pipeline webinar, and let's disable the versioning, and let's put some namespace that radon.blueprints.examples, and let's create this one. Now, once it is created, then we need to go to topology template, and over here click on open editor. So we will see the topology modeler window, and inside this window we can see a list of developed TOSCA node types. Using these node types, we will create this. We'll create this whole service template. Now, here first, what we need for this one, we need one Openstack VM. We need a AWS platform. We need to use the TOSCA node type for EC2. We need to use the TOSCA node type for NI5 for here, and as well as for over here, and some other data pipeline node types. So first, we need to create the Openstack virtual machine, and then we need to bring the AWS. Here it is AWS platform, and also above AWS we need to have one EC2 instance, and at the top of EC2 instance, and we need to create NiFi instances, sorry, NiFi software components. One NiFi software component will be at the top of, will be installed on OpenStack VM, and another one will be installed on the EC2 instance. So if we see for this service template, our our service template in TOSCA will look like something like this. So over here, yeah, it will look something like this. So we need to bring all the node types. So right now we have platform, we have EC2 instance, we have NiFi at the top of EC2 instance, we have OpenStack and NiFi at top of OpenStack. Now let's configure these things. So to configure all the things, like click over here, and then you'll see the list of properties you need to fulfill. So for example, over here in the key name, let us say in the OpenStack, I want to create a virtual machine, and the key name is, let us say, Chinmaya Dehuri. Then let us say the flavor is m2.medium, and image name is, let us say, CentOS 7. It's better to put the ID. SSH username is CentOS. The name of the virtual machine, we can put something like NiFi. I already have something, so let's put the name is this one, and the network we need to give, and then once it is done, okay, once it is done, now click on another AWS platform. Over here also we need to put the region name. For EC2 instance also we need to fill up some of the, we need to provide the required properties. For example, we need to give what is the image. SSH key name is, for me it is RADON pipeline, and then I need to provide the subnet ID, VPC subnet ID. Since we'll install the NiFi, it is better to put the instance flavor as t2.medium, and we'll provide the key file. We'll provide the key file through artifacts, and the SSH username is CentOS. So this is something similar. Some of the properties are similar to OpenStack. For example, SSH username and the image ID, the flavor, or the instance type. We need to provide these common properties. Now, similarly, we need to set the properties of NiFi instance. Here the port number we need to provide is like 8080, and web interface, it is by default it is false, but we can make it true for the debugging purpose. And let's put the component version, the latest component version, as 1.13.2. Similarly, we need to set the properties of this NiFi instance. Okay, and now for this EC2 instance, here I've said that SSH key file. The key file need to be provided over with the artifacts. So how to do this? Let's create an artifact, and artifact, click over here, artifact, then open this one. There is no artifact so far. Add a new artifact, and let's give the artifact name as credential file, which is of type file, and then upload the artifact from here. And I have already gathered all the key files needed. Okay, so let's add this one. Now we have added the key file with through the artifacts. This is one way of providing the key file. The other one is to upload the key file to the instance where we will run or where we'll orchestrate this service template. Now let's connect all those things. Let's establish the relationships among these nodes. So NiFi need to be NiFi needs to be hosted on the OpenStack instance. So here host, I'll drag to the host capabilities, and this is done. Now we need to, so EC2 instance should be hosted on the AWS platform. So let's connect this one to host capabilities. Okay, and now the NiFi instance need to be hosted on the EC2 instance. So it should be to the host capability. Okay, now we can see that EC2 instance is hosted on AWS platform, and then NiFi instance is hosted on EC2 instance, and similarly over here as well. Now what we need, what more we need? We need to also now bring the data pipeline nodes. First node is we need to have some data pipeline node to consume the data from min.io. And for that, we need to open the open palette, and then for consuming, we need to go to RADON nodes data pipeline.source, and here we have consume S3. Sorry, we need to have consume min.io, not S3. So let's delete this one. Yeah, consume min.io, and then this will send the consumed image file to a Lambda function. And to invoke the Lambda function, we need to have invoke Lambda node types. And since like we have two Lambda function, one for the image grayscale and the one is for image blurring, so we'll have two node types. And then we have two node types for grayscale and blur. We need to have another node type for publishing the data to Google storage. So let's bring that one as well. So we need to go to the destination and pub.gcs. Pub.gcs is for publish to Google Cloud Storage. And then we need to have one node type to invoke this fast function, and that fast function is already deployed, already created in the Azure Cloud Platform. And since we'll be sending the image data, it's better to have the data node. It's better to have the data pipeline node that is very specific to image. So this data pipeline node is mainly used to invoke the fast function through HTTP request, and the input is image type. So we have all the necessary nodes. Now we need to configure everything. And let us let's configure everything. We need to configure everything the same way over here. We need to provide all the properties. We need to provide the properties of consume min.io with the endpoint, with the credential file path, with the bucket name. Similarly, we need for Lambda function, we need to provide the credential file path through artifact. I have one service template which is already configured. Let's open that one and let us see. Yeah, this one. So the same service template is already configured over here. So to save time, let's use this one. So here we can see the NiFi instance is already configured properly. So the cons min.io we have configured with the min.io endpoint. We already have the min.io installed. That can be accessed through this IP and this port number. Here is the credential file path which we are giving through the artifacts, and this is the bucket name, and these are the three minimum requirement we need to provide. Now, okay. Now, with this lambda function, we will use this data pipeline node to invoke the lambda function that will grayscale the raw image. So here we are providing the credential file path through the artifact. It is the function name, lambda function name, and the region. And these are the three minimum things we need to provide, and we can leave other things as a default. Similarly, we will have another node type, another TOSCA node, data pipeline node that will blur the image. We have also provided the credential file path, the function name, and the region. This node type will publish the final image to Google Cloud Storage. Here also the minimum properties values we need to provide is the credential file path, the bucket name. So the bucket name is RADON CCS, and the project ID. We have another node, TOSCA data pipeline node, that will compress and store the image file, the compressed image file in Azure Blob Storage. So for that we at least need that function URL, and the HTTP method is post. And these are the two essential properties, two minimal requirements we need to provide. Okay, now we have connected everything. So whatever this node will consume the data, consume the image file from a MinIO endpoint, that will be passed to a image grayscale. This data pipeline node, and over here it will the image will be sent to a lambda function, and that lambda function will grayscale that image. Then the output will be forwarded to image blur, this lambda function. Over here the image will be blurred, and the output will be passed to two different data pipeline nodes. One is compress and store the data, the compressed image file. The other node type will be responsible to store that output to a Google Cloud Storage. So this is what we have, the service template, and also the artifacts. If you see here, we have provided all the artifacts, what are the necessary artifacts, and in the artifacts we are providing the credential files and the credential informations. So all are configured. Now let's save it, and once it is saved, let's close this window, and let's export this one. The service template usually will be in the format CSAR. So you'll see that I have already exported that one, and this is and this will be the service template. So since in this demonstrator we'll not use the Xopera SaaS version to deploy or to orchestrate our service template. So what we'll do is we'll use the C#, so we will use the CLI version of Xopera. So and for that, what we need to first download this one. So I've downloaded this one, DP webinar minus test one, and let's rename this one to unzip. I change the extension to zip, and then I can extract this one to here, but this folder is still there. Okay. Now extract this one to. Now I've extracted everything, and what we need right now is we will use this one in this service template. We'll use this service template will be used to orchestrate and to deploy all the node types or all the nodes. I have a virtual machine, and that virtual machine I have already installed the Xopera. Now let's Let's activate the virtual environment. Okay. What I'll do over here is everything I'll upload that one to my virtual machine where I have already installed the Xopera. And okay, let's do that one. Before that, there is one more step to do. What we need to do is, for the time being, we just need to modify the service template, the main TOSCA file. So what we need is we need to go to the definitions, and then in the blueprint examples, here we need to okay, here we need to change something. What we need is when we give this credential file, this is what we are giving in the GMT window. So we just need to remove this double quote to let it understand that this is actually not a string. Okay, so here also, and then this one, and then okay. Is there anything left? Okay, one more. Let's try to search if okay, nothing is there. That's good. Now let's save this one, and then what we'll do, we'll upload everything to the Xopera, to the virtual machine where we have Xopera. And okay, so here let us see. Yeah, now we have everything over here. Now what we need to do now is sorry, not this one. What we need to do is we need to configure the EC2 and Openstack key files. Not Openstack, but EC2 key file we need to configure. We need to make sure that this key file is having the right set of permissions. So what we can do here is that let's see the permission, or let's see the key file permissions, and that we can see inside service template, and inside is EC2 key files, this one. And here we can see that it is not 400. Usually the key file should have the permission of 400. So let's change this one. Okay, so what we can do here is that let's go to that directory. Sorry, let's go to the directory, and over here what we can do is let's change the permission of this key file. Okay, that's good. Now let us see. Yeah, now it's fine. Now let's get back to our original directory. Okay, so here we have everything. Now let's issue the Opera command, and Opera deploy clean, and then underscore definition. The main TOSCA file is always inside the definition, and the main TOSCA file name is usually RADON blueprint examples. So this part is the namespace, and then the service template name. So what we need is, let's copy the name of this file and let's put it here. So here we just need to give the path of that TOSCA file, and Opera deploy and clean. Clean means always start from the very beginning. Now let's start with this one. Okay, so this one will take a little bit of time, in the sense that it will this one will do this one will install everything. will create everything. For example, this one will create the virtual machine, will install NiFi at the top of that, and also this one will create a EC2 instance and install NiFi at the top of that. Then it will deploy all the data pipeline nodes at the top of NiFi. So it will take a little bit of time. And let us, okay. In the meantime, what we can do is, let's open, let us see the RADON storage. So here is the RADON GCS, this is the storage in the Google Cloud, and this is the storage, okay, yeah, this is the storage. Here basically we'll get the compressed image, compressed blurred image we'll get. And we already have the NiFi instance. This NiFi instance where like we'll upload the image file to here, and we will see the compressed file in this, we'll see the compressed file in this Azure storage, and we'll see the blurred image in this Google Cloud. So, okay, so now let's just wait for the X operator to deploy everything. It is now creating an EC2 instance. Okay, now it tries to install NiFi, and for that to accept the fingerprint. So it will go one by one. So first this one deployed the AWS platform. So AWS platform is deployed. Then it will deployed the Openstack. So that means it created this Openstack VM, created the Openstack VM, and then it deployed the EC2 instance. So EC2 instance is already deployed, and that means the whole EC2 instance is created, configured, and now it is deploying the NiFi instance. Okay, and now we see that PUBG says this is already like created, configured, and it's already like started. And now it is creating this node. So it is mainly like creating this invoke image pass function node at the top of NiFi in software component. Okay, this is configured. Okay, now it is deploying invoke lambda 10. It is this one. Okay, so we see that all the node types are already like created, deployed, and started. Now it is creating this one, this NiFi instance at the top of Openstack. It's now configuring this NiFi. It's like starting now, and after this it will deploy the cons min.io node type. Now it is deploying cons min.io. This configuration means like configuration to establish this relationship. So once this is created, so before it before that we need to configure this one with this node. Okay, it seems like all are deployed. All the node types are already deployed and started. Now what we need to verify that everything is working or not. So if we see, we will upload the data to here, to the min.io database, and we should see the result in the Google storage and also in the Azure storage bucket. So what we can do is first let's upload some of the image file to this min.io database. Here we'll upload the data to first bucket because if we see in the definition, if you see like we have given, we can see, I guess, the properties underscore definitions and then RADON blueprints, great, okay. And if we see that in the min.io we have given the first bucket, yeah, in the min.io we have configured the properties of bucket name as first bucket. So what we need to upload the data to that first bucket here. So let's put some data. Let us say that let's say we'll upload this data to min.io, and instantly without taking long time we should see the result over here. If not, then we need to see where is wrong. Okay, we don't see anything. It should happen very quick. Okay, if it is not happening, then probably we need to see the NiFi instance. NiFi instance, we need to see the NiFi instance top of OpenVM and the NiFi instance at the top of EC2 instance. So for NiFi instance, to access this NiFi instance, we need to have the IP of OpenStack VM. And let's see what is the IP of Opera instances and then OpenStack. OpenStack. And here we can see the public IP is this one, and then we can browse this one, and with the port number 8080. Okay, here we can, okay, so here I see that, okay, this is this should be enabled. Okay, anyway, now this is enabled, but we can see that there is like in the queue there is one file and now it is paused. And let us see if it is, if we are able to see. If not, we just need to little bit of debug. So this is for the second NiFi instance over here, and let's see that one. 52 dot, it was 18.38.57. This is the EC2, this is the IP of this EC2 instance. And if we'll see here how to get the IP is from here. So inside this .opera instances, we'll see the properties of this EC2 instance, and here I see the attribute of this EC2 instance as this is the IP address of this EC2. So what I can do, I'll just get this one, and yeah, this is the same, and the port number is 8080. So I can see the NiFi instance here. Sometimes some of the processors or some of the things are not running. Here we can see that something is stopped over here. That should not be. Okay, this is the public GCS. This one is something. We see that it is stopped. Let's start it. Yeah, now we started. Now we should be able to see the Google storage bucket, and we should be able to see that image file. Yeah, we see the image file here. So here we uploaded the skin PNG, and here we see the screen PNG, and let's open this file and let's compare with the original file. We had the original file. This was the original file, and we can see here it is already like grayscale and blurred as well. Now the compressed image of this one should be in the Azure storage. Okay, let's refresh. Yeah, we see this screen png.gz. So if we download this one and let us extract this file, and okay, screen png. Okay, inside we can, here we can see the thumbnail itself. We can see the image file. Sorry, seems there is some issue. Anyway, here we can see the image file, blurred and grayscale image file, which is the output. So what we did, we create this service template, and we created the service template using different data pipeline nodes, and we see how it is. After creating this one, we see how it is very easy. Once it is created, then we need to configure all the properties, artifacts, and their relationships. Once it is done, then we deploy that one using the X-Opera's orchestrator, and we use the CLI version of that orchestrator. And once it is deployed, we see that if anything will upload, that one will be grayscale, will be processed using the Lambda function. That one will be processed using the Lambda function, and then it will be stored to the Google storage. So here we see that we uploaded this file, and we see that in the Google Cloud Storage we can see one.jpg, which is also grayscale and blurred as well. So this is all about the webinar, and this video will also be part of the webinar on RADON data pipeline. If you want to know more, you can log into the Eclipse. You can log into the RADON IDE. You can contact us if you want to know more a little bit inside the other types of data pipeline. And that's all about this demonstration. Thank you very much. Bye bye.